Hi Math 20-1 and welcome to lesson 25 part 2, reciprocals of quadratic functions this time. Alright, so this one's actually going to be really similar to part 1. There's not much of a difference here. So just to recap, in part 1 you would have had something like this. So you'd start off with f of x is equal to 2x plus 4, right, something like that. And it was linear functions is what we were doing, so that makes sense because that would just be a line if you graph that, right? And then we'd figure out what the reciprocal was. And remember, the reciprocal, we just called it y, just the symbol y, just, there's no, like, it's not necessarily y, we just kind of called them y instead of, like, you know, f2 of x or something like that, just to keep things simple. So we'd say y, the reciprocal function, is equal to 1 over f of x. Right? And in that case, f of x is just this, right? 2x plus 4. So we'd say y is equal to 1 over 2x plus 4. Okay, so that was it. And then you could figure out from there, let's say if we looked at this, right? Well, remember our vertical asymptote, right? Our non-permissible value? Well, that would be where this, right, where f of x is equal to 0, because you can't divide by zeros, right? So when you graph that, it would never be that point. So that's going to be our vertical asymptote. So you'd say, well, let's just figure out where 2x plus 4, what would make that equal to 0. So you could say 2x plus 4 and make it equal to 0, right? So then you could subtract 4 from each side, so you get x is equal to, 2x is equal to negative 4, and divide by 2, divide by 2. So you get that x is equal to negative 2. So at negative 2, our new graph, right, wouldn't, nothing would ever touch that point, right? And then remember, we had those things called invariant points. Oh, I don't want that. Those things called invariant points. So that would be when, remember the invariant points would be when f of x, so in this case there, right, when that was equal to either 1 or negative 1. Right, so when that was equal to 1 or negative 1, then that would end up being the same, like y would end up being the same. That would, so if f of x in that case, let's say that was equal to 1, well then 1 divided by 1 would be 1. So they're the same, they're invariant, they're the same for both, right? Or if it was negative 1, right, if f of x, right, if that was equal to negative 1, then 1 divided by negative 1 is negative 1, right? So they're both the same, so they're invariant, right? So that's kind of an easy way to figure out where these things would go. So when f of x, right, the original function, right, so that's this line we had, right, when the y value of that, right, f of x was equal to, let's say, negative 1 and 1, right, so at those points, then they were invariant. So from that, you can get a quick little sketch there. This thing would have looked like this, right? It would have come there. So remember, it approaches the horizontal, or sorry, the vertical asymptote, and it just never quite gets to the x-axis like that, right? So it does like a loop like that, and then we get something similar in the top. So we come down here, pass through there, and go that way, right? So really quickly, that's what you guys did in the last video there. So something like that. Okay, so now what we're going to be doing is the same thing, but instead of it being a linear function, it's going to be a quadratic function. So something like x squared minus 9, right? That gives us a parabola. Okay, so let's look at an example here. I think will be the best way to do it. All right, so I'm going to change it to x squared minus 4, just because we can do a few more things with this one than the one I had written there. So it should be x squared minus 4 on your sheet. So, all right, so let's do this example. It says sketch the graphs of y is equal to f of x. All right, so first off, we're just gonna sketch the original function here. So let's sketch f of x is equal to x squared minus 4. All right, so we know some things about this, right? So first off, really easily, the number hanging off the end there, negative 4, that has to be our y-intercept, right? So we know that. We know that it's opening up, right? It's positive, so like happy face would be opening up, right? And then, well, the other handy thing here would be to know what our x-intercepts are, right? Well, the x-intercepts happen when our y value is 0. So when f of x, when this is 0, then, you know, what would x have to be to make that true? Well, what we can do is factor this. So we're going to factor it. We both get an x. And this is a difference of squares, so it would be minus 2 and plus 2. All right, so where does this happen? So that one would be when x is equal to 2, and that one would be when x is equal to negative 2, right? So that's our x-intercepts there. So let's plot those. So it's going to happen at negative 2 and at 2. That's really enough just to sketch our original graph, right? So I'm going to just, best I can, I'm not very good, but down with that, and then back up. All right, so it'd be something like that. That's our original function of f of x is equal to x squared minus 4, right? All right, so now what we're going to do is figure out the reciprocal of that, right? So the reciprocal, do a different color here, would be so we'll just say y is equal to, and then it's 1 over f of x. Okay, so f of x in this case, though, was x squared minus 4. So let's write it like that. We'll write it as y is equal to 1 over x squared minus 4. So that is the reciprocal function, right? So now we just need to be able to graph this thing. And to tell you the truth, you could just one by one keep throwing numbers in for x and then plot them, right? That would work. You could do that. It would just, yeah, it'd be fine. Yeah, like that would be a fine way to do it, right? But usually what we want to figure out in these cases is our vertical asymptotes, right, when we're doing these reciprocal functions, which really are our non-permissible values, right? NPVs are what they're sometimes called, NPVs. And that's really when you're dividing by 0, right? You're not allowed to divide by 0. So we really want to know, okay, when is f of x equal to 0? So really, when, what would x be to make the bottom here equal to 0? Well, maybe you can see from above what they would be already, right? But maybe not. If not, let's write it down. So y is equal to 1 over, and then we're going to factor these again, just because it'll make a bit more sense. So we've already factored them, so let's do it again. So just x minus 2 and x plus 2. Okay, so then from this, I can see it a little bit more clearly what would make the bottom, right, my f of x equal to 0. Well, in this case, right, let's say I threw a 2, a positive 2 into that x right there, right? Well, then that would be 2 minus 2, which would be 0. And then 0 times anything is 0, right? So that just made the entire bottom 0. And I can't divide by 0, right? So a non-permissible value here would be when x is equal to 2. And then it's the same thing for the other one. If I threw a negative 2 in for that one, the negative 2 plus 2 is 0. That makes my entire bottom 0. So then 1 divided by 0 is non-permissible. You're not allowed to do that, right? So it's also going to happen when x is equal to negative 2. Okay, so what we just figured out there are what our vertical asymptotes are, right? It never touches that line. Okay, so let's use green maybe. And a bit of a coincidence, I don't know. They happen at the exact same place as the x-intercepts for our first function. Well, that makes sense, right? That's always going to be the case there. Okay, so down there. So they never touch those points, right? So, and it's going to be something similar, just to get you guys thinking about this. It's going to be something similar to what we did up here, right? You got these like swoop things happening on either side as they approach that line. It's going to be similar to that, but we've just got 2 of them now. So, all right, see if we can make sense of this. So again, if I wanted to figure out what the graph looked like, I could just all day long just throw numbers in for x and then just figure out what you get out for y and just plot those individually, right? If you got time in the test and you want to really make sure you're right, you could just do that. Just throw 1 in for x, throw 0 in for x, throw negative 1 in for x, throw 10 in for x. You can throw anything you want in for x and see what you get out for y. Those are all points on your graph, okay? But if we're just sketching it, there's a couple of things we can do here that can make it a little bit easier. And one of them is to figure out what our invariant points are. So remember, and I did that in the top one too, right? Sorry for the scrolling. The invariant points in this case, right, were there and there. That's where they're the same, right? So that's, I talked about that there, right? So that's when f of x was equal to 1 or negative 1. Well, we got the same thing happening down here. It's going to be exactly the same. So when our original function, right, when this was equal to 1 or negative 1, that's where they both have the exact same numbers. That would be there and there. Would be when f of x is equal to 1. There's 2 of them, right? There's going to be 2 places where that happens. And there would be two places where it happens on the bottom, at -1 and -1, right there, right? Okay, so now it's starting to come together a little bit, you know, like for example, let's say, I don't know what color should blue. Okay, the top here, what's going to happen here is, remember, because it approaches the x-axis, right? I know that this one here would have to come down, pass through that invariant point, and then go that way. Like, I know that that's the case. And then the same thing happens on the other side. It would come down. Oh, that was terrible. Just bear with me. You know what I should have done, right? Should have approached that line, not veered away like I had it, but you get the idea. Okay, so that's what would happen on those sides. But then what's happening in between here, right? How does the graph look in between? Well, really, between these 2 points, the only thing it would do if it's approaching here, right, is it would go up like this, pass through there, and then go through the other invariant point, and then down again. And like I said, you can try these out all day long, right? So remember from the last video, if I go 4, right, or sorry, -4 here, that's our y value, or from the original one, right? So if I go y, oh, shoot, what's happening? Y is equal to, remember it's 1 over f of x. So if I go y is equal to 1 over -4, okay, well that'd be y is equal to -1/4, right? So that's what this should have been, right? -1/4 at that point. And you can do that all day long for like all the points, right? But that's the gist of it. That's how it would look. So it's our blue function, right? That's what our new reciprocal function is going to look like. They're kind of strange, right? They're not kind of, maybe not that intuitive. Like they're all kind of broken up every which way. But that's kind of the general idea on those. So now I sketched it all out, but let's actually figure out what these things are. So let's it says for both graphs, label the asymptotes. All right, so we did that. Let's make that green. All right, so the asymptotes there, right? So we're going to label those. So those are going to happen. So remember, this is a vertical line, right? So that would be when you'd say x is equal to 2, right? Vertical line is not, instead of y is equal to, it's x is equal to. So x is equal to 2. And then on this side, you'd say x is equal to -2, right? So that's what those green dotted lines are. All right. And then the invariant points, right? So I kind of went over that where they were here, right? But I never did really figure out what the x value would be on those, right? So we should actually figure those out too if we're actually going to label those as an actual point, right? So what we're going to do, let's do that one right now. All right. So where is this going to happen? So I kind of already, that was from the last video, but let's say, so that's going to happen, remember, when f of x is equal to 1. So here. So the original function here was f of x is equal to, and then what was it, x squared minus 4, right? And then remember the reciprocal function of this was 1 over, like y is equal to 1 over f of x. So I want to know like where these things are the same. Remember that happens at 1 and -1. When f of x is 1, right? So when this is 1, 1 divided by 1, I get the same point for y. When it's equal to -1, I get the same point for y, right? So they're invariant. They're the same for both those graphs. So all I got to do if I want to figure out what the invariant points are, what the x value is, I know the y value is 1 and -1, right? But what I got to do here is just go, okay, when f of x, when this is 1, then what's x? So I can say x squared minus 4. Okay, so now we just need to solve for x here, right? Okay, so what we're going to do is we're going to add 4 to both sides. So we'll say plus 4. No, that was terrible. Plus 4. All right, so I get 5. So x squared is equal to 5. All right, so very last thing I got to do is take the square root to get rid of that squared, right? So square root. So right now I've only got one answer though, right? I've got x is equal to square root of 5. Well, that's weird because I should have two answers, right? Because I know right here, right, this invariant point, that would be at, you know, well, let's say we figured out, oh, that, we just, well, square root, not a 5. All right, square root of 5, comma 1, right? When y is 1, x is square root of 5. So I figured that out. But what about this one? It's something, comma 1, right? I know it has to be 1, but what's that something there? Well, that's, we're forgetting something from the last unit, right? Or from the first unit. Whenever you take the square of a number, you actually got the positive and the negative version of it. So it's actually two answers are right there. You get plus or minus root 5. So this would be negative root 5, or root 5. Negative root 5, right? Okay, so that's that one. And then we'll just have something really similar on the bottom, right? So that was the first one there. And then on the bottom, we're going to have negative 1, right? The other invariant point is equal to x squared minus 4. So again, I'll add 4 to both sides. So we end up getting 3 is equal to x squared. And then again, just square root, square root. All right, so we get x is equal to plus or minus root 3. And we just leave it like that, right? Because I don't know what root 3 is. So that invariant point would be negative root 3, comma, negative 1. And then this invariant point would be at root 3, comma, negative 1. All right, so we got our invariant points, so we labeled those. What's next? All right, and the intercepts. All right, so we really did that, right? So our intercepts here, maybe I'll make it red just so it's the same, right? That's also going to be at x is equal to 2. And then x is equal to negative 2. They would be the same as our vertical asymptotes there, right? You know what, just for the fun of it, let's write down the domain and the range for the reciprocal function, right? This wasn't in the question, but just, it's not too bad. I just want to make sure you guys know how to do it if you see it. So the domain, I'll just say D. And remember, domain is what is x allowed to be, right? So even though this looks all confusing with the blue line here, right, because that's our new reciprocal function, there's just 2 points that it's not allowed to be. It could be anything, right? It goes forever this way, and it goes forever that way. It just can't be 2 points, right? So we just say that x is not allowed to be, right? So x cannot be equal to, and you could even do it in one, just say plus or minus 2. You can write it as one number there, right? You could say plus 2, comma, negative 2, that's fine. And then just where x is a member of the real numbers, right? So now I've just kind of covered everything, right? X isn't allowed to be plus or negative 2, but it can be everything else. That's kind of what that's saying at the end there, right? X is a member of the real numbers. And then our range, right? So that's what y is allowed to be. So then y is just not allowed to be one number here. Y is just not allowed to be equal to 0. And that'll change in this one for 20-1. It's pretty much always going to be, it can't be equal to 0. In 30-1, we'll start shifting these things around so that y, it could be y is not allowed to be equal to 1 or something like that, right? But for now, it's always really going to be that. And then again, you just say where y is a member of the real numbers. Okay. All right. And then lastly, I'm not going to go over it. I think you guys will be all right because it's the same as the first one, right? I showed you guys how to do it pen and paper, right? So we could figure out everything by pen and paper. But what you could always do, especially if you want to check, right, is we could have graphed both these things, right? So we could have, in your calculator, right, we could have said f1 of x is equal to x squared minus 4, and then you could have graphed it. And then you would have also graphed f2 of x, or y1 and y2, is equal to, and then graph 1 over x squared minus 4. And just make sure it goes in your calculator properly too, right? So when you type that in, you should type it in as 1, and then divided by, and then brackets x squared minus 4, right, to make sure that goes in properly, especially if you're using a TI-84 or TI-83. Usually TI Inspire will kind of figure out what you meant, but sometimes it'll be wrong too, so just make sure that it goes in properly. Okay, and then once you've got both of those in there, right, then you can figure out all these things using the methods that we've done before, right? You could figure out what your non-permissible values were, really just by figuring out what the intersection was, right? So you just go to the left of it, go to the right of it, and doing those things that we've done already. You could figure out where your x-intercepts were there. The only thing that wouldn't come up so obviously is the vertical asymptote, right? There's no button to figure out what that is, but you should be able to figure out that it's exactly the same as the x-intercept of your original function there. Okay, so as long as you know that, right? The calculator won't tell you that one, but everything else you can figure out with the calculator. It's a great way to check too. Maybe on the test I tell you to do all this by hand, but if you want to check your work, calculators, graphing things is a great way to do it. Okay, so that's it. Questions for you guys to do. Make sure you don't forget these. You guys are gonna do these questions, please. Okay, so that's it for that video. See you guys later.